This is part 2 of Tube Life, vacuum tubes, not the British Metro. So let's focus on our vacuum tubes right away. So our part is now called Filament Continuity. So this is one key aspect of vacuum tube longevity. How happy is that element that heats up your tube? So as you all know, when you are using a vacuum tube, then you need a so-called filament transformer. So that's the primary side, and that's the secondary side of your transformer. And here you are connecting, we show it if it's an indirect heated tube, it's shown like a V sign. If it's a direct heated tube, then it's shown like a semicircle. That's the sign that we use in schematics for representing the filament, the structure that heats a vacuum tube. So why is the filament itself important for tube life? It's because the filament is needed to heat up the tube because there is vacuum inside the vacuum tube. And when you apply the high voltage between the plate and the cathode, then the electrons cannot fly if the cathode is not hot. You have to make it hot, and then they are able to emit electrons. And those electrons will be sucked up by the high voltage from the cathode to the plate. And it's the filament that makes this possible. And now there are some issues that we have to look at when we look at the filament, and one of them is the filament voltage. So for example, you have a rectifier tube which has a 5-volt filament. So such a tube is the 5R4GY, and this is the rectifier tube that Audionaut uses for many of their amplifiers, including the Ongaku. Now actually the Ongaku doesn't use this guy, but their 45, 2A3 and 300B amps use this tube. And so it's a 5-volt filament. It means that you need to apply 5 volts AC or DC between the two filament pins. And the voltages are specified in such a way that they have to be within 10% tolerance. So you are permitted to be 10% higher or 10% lower. So to safely operate the tube, it has to be between 5.5 volts and 4.5 volts. If you go outside this range, then the tube life will drastically change. And it will be drastically shorter if you go higher. So actually, when you look at an approximate tube life, which depends on the voltage applied on the tube and the amount of current that is asked to be drawn. And when you take all of those into consideration, if you keep the voltage exactly at 5.0 volt, that's when you get its nominal lifespan, which is usually around, let's say, 10,000 hours for this vacuum tube, provided that you run it well under plate dissipation, but it's a pretty heavy duty operation. And if you run it at 5.0 volts, then it will heat up your cathode to approximately 1200 degrees Celsius. So that's the operating temperature of the cathode, and that's where it's designed to run at optimum efficiency. So if you drop it down to 4.5 volts, then the voltage, the temperature drops to 900 degrees Celsius. So tube operation is optimal at this point. If you drop it to here, then the tube emission will be a little bit lower, I would say noticeably lower. But also if you drop the voltage slightly, because of the lowered emission, you are increasing the tube life tremendously. However, because of lowered emission, you are also compromising the sound of the tube. If you drop it to, let's say, 4.9 volts or 4.8 volts, then you will not really hear noticeable change in the sound quality, but you will see a major increase in the lifespan of the tube. If you drop it to 4.5 volts, then you will notice a big change in the sound quality. It will be much less dynamic, but then the tube life will be like 2, 3, 4, or 5 times longer compared to running it at 5 volts. It's because you are sparing the cathode. So because of the colder temperature, the emission is much slower, so your cathode will last much longer. However, there's the other option, that when you heat up your tube to a higher voltage, then you can get, let's say, around 1300 degrees Celsius or even hotter temperatures for the cathode, and then you are hastening the death of the cathode. So this process is called depletion. So this is when the barium oxide layer on your cathode is just gets stripped faster than it should be, and your tube life is easily halved, or it gets a third of what you could get out of the tube when you run it so hot. It will sound more dynamic as well, but also it will sound stressed too. And that's what we can hear in a number of vacuum tube amplifiers, when the companies just decide to torture the tubes inside and make them run hotter with really hot filaments, and that will force the vacuum tube to have a lower plate resistance, to have a higher current handling capability, but it will be higher than what the tube is designed for, and it will appear in the sound that the amp sounds stressed. You can really hear it in the sound when the vacuum tube is being tortured. And if you run it at even hotter temperature, like say 6 volts, then the temperature is so hot that basically you are cutting down the tube life to 10% of what should be the normal expectancy. So instead of 10,000 hours for this tube, you will get 1,000 hours or less. However, there's another interesting thing. If you drop the voltage too much, so you drop it below 10%, let's say you drop it to 3 volts, it means that in that case the cathode is way too cold, so it's barely warmed up to emit electrons, and in that case, instead of emitting electrons, the plate will start to strip the barium oxide layer from the cathode. So when you look at these indirect heated vacuum tubes, they have inside the filament structure. For simplicity, I draw it as a loop wire, and around this there is a tube. So there's a tube around this loop, and that's the cathode. And the cathode is a metal which is coated by a few microns thick layer of barium oxide or some other oxide, and this oxide layer needs to be heated up, and when it's heated up, then it can release electrons to the plate. If it's heated up too much, then the electron release process is too fast, and it will deplete the oxide layer, because there's only a certain amount of electrons that this layer can emit during the life of the tube, and once it's gone, there's no more left. If we cool the temperature to too cold, so such a cold temperature that it's not enough to release electrons, but it's already warm enough, then the plate voltage will strip the barium layer itself. So instead of the electrons, it will strip off the oxide, the oxygen atom from the barium oxide, and then that will leave that stripped an inert, an incapable cathode in the wake of the process. So that's why it's really critical for indirect heated tubes to run them at a correct temperature. I like to run them like 2% or up to 5% less than the nominal voltage, and then your tube will live like really, really long, and the sound is not impacted. But I can tell you guys that never ever run the tube higher. Just make sure, check the voltages in your amp. If it's rated for 5 volts, make sure it's 5.0, between 4.8 and 5.0. Don't let it go higher. If it's 6.3 volts, then anything between 6.1 and 6.3 is fair game. I like to run them at 6.25 or 6.2. At 6.1 you can already feel that the signal tube is getting weaker, so I like to clock them to 6.2 watts. So that's about the filament continuity. Let me see. So eventually I have not mentioned, so I just described how the filament works for an indirect heated tube, which is called like an IDHT, indirect heated, triode, tetrode tube, whatever. However, what filament continuity means, because now what we have talked about, that's the cathode depletion based on the voltage of the filament. There's the other part, which is the filament continuity. It means that this wire is continuous, and each time you turn your amplifier on and off, that's a big stress on the filament. And the filament, if you would look at it through an electron microscope, and if my pen would write, let's see that we have magnified the filament to this size, then it has microscopic impurities inside the filament. And when you turn your tube on, and then it heats up to 1200 degrees Celsius or a little higher, then because of that extreme heat, it melts slightly, and it affects these impurities. Those impurities are getting worse and worse, because they are also reacting from the free atoms inside your bulb. So over time, as you switch it on and off, with each heating and each cooling cycle, so you are heating it up from basically like 20 degrees Celsius to 1200 degrees Celsius, and then cooling it down from 1200 to 20, and each time you turn your amp on and off like hundreds of times during the lifetime of the tube, then these impurities are getting worse and worse and worse. And after a while, when your impurity is so big, then your filament will stop conducting. It might physically snap, or it just might change the resistance of the filament to such a degree that it cannot do its job anymore. And then your tube will die because your filament cannot work anymore. And such a filament discontinuity is a sudden death for the vacuum tubes. So your tube has been working fine, and then you turn on your amp and the tube doesn't light up. And when you plug it into your tube tester and you test for filament continuity, there's no continuity. That's because of this process. And there is an elixir to prevent or to postpone such problems, and that's for the next part. Thank you. Please like, subscribe. Bye bye.